Before going to start exercise 18b, I just want to explain those theorems, what you need to learn to solve problems from 18b. Theorem 12. See, if two chords of a circle intersect internally or externally. In this picture, these two chords AB and CD, they have intersect internally at the point P. Okay, then what happened? Then the product of the length of their segments is equal. Length of their segments means, see, AB and CD, they have intersect each other at the point P. And by this intersection, that chord divided into two segments, PA and PB in case of AB, and PC and PD in case of CD. Product of their length of these segments are equal. Product is equal. That means PA into PB, that is equal to PC into PD. Okay, this length of this PA, this one and that one PB. So PA into PB, that will be equal to PC into PD. Okay. Now, this is the case where chords intersect internally. And in case of this picture, see this picture. Here they have intersect externally. In that case also, PA into PB, that is equal to PC into PD. Okay. Now come to theorem 13. Theorem 13. Angle between a tangent and chord through the point of contact is equal to an angle in the alternate segment. What it means? See, this is a circle whose O is the center, and here PQ is the tangent at the point A. So at the point A, there is a chord AD and AB, right? AB is a chord. Now, AB is a chord, and if you choose any point from this segment, AB divided this circle into two segments, this one and that one. Okay. Now from here, if you choose any point, suppose C, this chord will make an angle at C, ACB, that is the point. Now this that is the angle. Now this angle will be equal to the angle what that chord make with this tangent PQ. So that means QAB, that will be equal to BCA. And if you consider this angle for the same chord PAB, this angle, this one, so then this angle, it will be equal to any angle in its opposite segment. That means this segment ADB, that will be equal to PAB. Okay. Now theorem 14. If a chord and a tangent intersect externally, so this is chord AB and this is tangent that PT. If they have intersect externally at the point P, then product of the length of the segment of the chord is equal product of the length of the segments of this chord. That means PA into PB. Okay, that will be square of the length of the tangent from the point of contact to the point of intersection. So point of contact means this one T, and point of intersection, that is P. So PT square, that will be equal to PA into PB. Okay. So exercise 18b, question number 1. In this figure, AB and CD, two intersecting chord, they have intersect each other at the point O, at the point O. So obviously OA into OB is equal to OC into OD. Okay. So that means OA by OC is equal to OD by OB. Okay. Now OC is to OA is to OC, that is given to you, that is 4:7. So that means OB by OD, that will be 7/4. So 7:4. That means option 3 is the correct answer. Next one, see, if PAC is to PCA, that is 5:4. So you have to find out P. Okay, P. Now see one thing, here AB and CD, two chords, they have intersect each other externally. So what you can write from here, see, PA into PB is equal to PC into PD. Okay, so that means PA by PC is equal to PD by PB. Okay, now you know that ratio of the angles opposite to the sides, that will be equal to the ratio of the sides. So that means PA by PC, that means PA opposite angle of PA, that is PCA, this angle is the opposite to PA, that one, by PAC, this angle, that is opposite to PC. So from here you can say angle PCA, that is the opposite angle of PA, and PC, so opposite to this one means PAC, that is equal to, so PD is here, so opposite to PD, that means this angle, this is 60 degree, so this is 60 degree, and PB this one, so PDB, so this will be angle PDB. Okay, now see, PAC is to PCA is 5:4, that means PCA by PAC, that will be 4:5, so that is equal to 4/5. So that means angle PDB, that is 5/4 into 60, 15, so that will be 75. Okay, so this one is 60. See, PBD, that is in case of triangle PBD, this angle is 60, this angle is 75, so this angle will be, angle P is 180 minus 75 plus 60. So option 4 is the correct answer. Okay, option 4 is the correct answer. Now see question number C. AC is the tangent given to the given circle, which touch the circle at the point B. This is the point B. If EBC, this one is 45 degree, then EDB is equal to, you have to find this angle. Now see, EBC, that is equal to EFB. Why? Because they are angle of alternate segment. Angle EFB is equal to angle EBC is equal to 45 degree, because they are angle alternate segment. Now this one, if this one is 45 degree, so this one will be 180 minus 45, because BDEF is a cyclic quadrilateral. So angle BDE, that will be, or EDB, whatever may be, that will be 180 minus 45. So 135, that means option 4 is the correct answer. Okay, now next one. See, in the given circle, PA is the tangent and PBC is second. PA is the tangent, PBC is the second. PA is given to you. PA is 8 centimeter and PB is 4 centimeter. The length of BC, you have to find out length of BC. Now you have one theorem 14, the last one. PB into PC, that is equal to PA square. Now PB, here PB is 4, PC equal to, PA means 8 square, so 8 square 64, and that means PC is equal to 64 by 4. Okay, so 16, so PC is 16, PB is 4, so BC equal to 16 minus 4, that is 12 centimeter. So option 2 is the correct answer. Okay, see the question. In the given figure, O is the center of the circle. Okay, O is the center of the circle and PA is the tangent, PBC is second. If ABC is given to you, you have to find out angle P. So see the figure. See this is the figure. Okay, so here ABC is 60 degree. Okay, see, angle ABC is 60 degree. Okay, now BC is the diameter, so obviously angle A is, BAC, that is 90 degree, angle on semicircle, so angle BAC, that is 90 degree. Okay, so that means angle ACB, that will be 90 minus 60, so it will be 30 degree. Now angle ACB, this one is equal to angle PAB, so angle PAB, that is equal to angle ACB, that is equal to 30 degree. Now see, ABC, that is the extension, ABC, that the exterior angle of this PAB, this PAB is a triangle and ABC is the exterior angle. So that means angle APB, that is P, plus angle PAB, that is equal to 60 degree. That is equal to 60 degree. That means angle P is equal to 60 degree minus PAB. PAB means 30 degree. So that will be 30 degree. So option 1 is the correct answer. That will be 30 degree. So option 1 is the correct answer. See, in the given figure, diameter is AB and chord CD is the of the circle meet at the point P, and PT is the tangent to the circle. So that means AB, this one is AB. AB produced meet the chord produced of chord, CD produced, that is at P, at the point P, and PT is a tangent. Okay, so here some points are given to you. CD is given to you. CD is 7.8 centimeter. PD is given to you, that is 5 centimeter. So PC, you can easily calculate PC. Now PA, PB, so AB is a chord, CD is another chord, diameter, AB is a diameter, that means it is also a chord. So what you can say from here, by theorem 12, first thing, what you can say, that is PA into PB is equal to PC into PD, right? That you can say. Now PD is given to you, PD is 5, and PC is PD plus CD, right? PD plus CD. So that means 5 plus 7.8, that means 12.8. So this one into 12.8, and PB, that is given to you, that is 4, and PA is not given to you. So you can easily find out PA. So PA is equal to 5 by 4 into, so if you divide, it will be 3.2, and if you multiply, it will become 16. Okay, 16. So PA is 16 centimeter. Okay, PA is 16 centimeter, and PB is 4 centimeter. So AB will be 16 minus 4, that is 16 minus 4 centimeter, that is 12 centimeter. Okay, so AB is, you have got AB, right? So this is the answer of first one, AB. You have to calculate AB, and AB is here 12 centimeter. Now length, now you have to find out length of PT. Now obviously PT, see, PA into PB, that will be PT square by theorem 14. Now if you multiply this 2, you will get 4 into 16, that means 64, that is PT square. 64 means 8 square, so that means PT equal to 8 centimeter. Okay, this one, this is the length of the tangent. This is the answer of question 2. Okay, so in this following figure, PQ is the tangent to the circle at the point A, DB is the diameter, O is the center of the circle. If ADB, this one is 30 degree, and CBD, this one is 60 degree, that is given to you. So you have to calculate QAB, PAD, this one, and CDB, this one. Okay, so QAB, see this figure minutely. PQ is the tangent, right? PQ is the tangent, and AB is the chord, right? Now QAB, this angle, and ADB, this angle, they are angle of alternate segment. Okay, so ADB is the angle of alternate segment of this QAB. So this two angle will be equal. Angle QAB, that will be equal to angle ADO or ADB, whatever may be, because they are, because ADB, actually ADB is the angle, ADB is angle of alternate segment, okay, of angle QAB. Okay, so that means it will be 30 degree. Okay, so first, this is the answer of first question, QAB, this one is 30 degree. Okay, now PAD, this will be equal to that angle. AD is the chord, AD is an AB is a chord, and AD is another chord. So PAD, for the same reason, PAD, that is equal to angle ABD. Okay, now see, O is the center, DB or BD is the diameter. So that means this, if this is 30, this will be 90. Angle DAB, that is 90 degree, because angle on semicircle. Okay, so this is angle on semicircle. So angle ABD, that will be 90 degree minus 30 degree. Okay, so this will be 60 degree. Okay, so ABD is 60 degree, that means PAD, that means angle PAD, that will be 60 degree. That is the answer of question 2. Now come to the last part, angle CDB. This angle, this one. See, DB is the diameter, so angle C is 90 degree. So angle DCB is equal to 90 degree. Why? Because this is angle on semicircle. So DCB, triangle DCB is a right triangle, and angle BDC or CDB, whatever may be, that will be 90 degree minus 60 degree. So that will be 30 degree. Okay, this is the answer of 3. Okay. Question number 4. PQ is the tangent of the circle at the point R. Okay. Now you have to calculate PRS, so this angle, ROT, this angle, O is the center that is given, and angle TRQ, this one is given to you, that is 30 degree. Okay, so RST, this one, see this angle. Question number 4, angle TRQ, that is 30 degree, right? PQ is the tangent at R, so RT is a chord, PQ is tangent at R. So that means angle RST, that is the angle on alternate segment of this TRQ. So that will be equal to angle TRQ. Okay, angle on alternate segment. Okay, so that will be equal to 30 degree. So RST is 30 degree. This one is 30 degree. Now see, O is the center. So ST is diameter. So this angle SRT is angle on semicircle. So that will be, so angle SRT, that is 90 degree, because angle on semicircle. So this one is 90 degree, this one is 30 degree. So in case of this triangle SRT, this RTS, this angle will be 60 degree. So angle RTS, that will be 60 degree. Okay, and that will be equal to PRS. Why? Because this one is the angle on alternate segment of this chord, of this angle. See, RS is a chord and this angle PQ is the tangent. So this angle and that angle will be equal. Okay, so this is also 60 degree. That is the answer of question 1. Okay, now the next part. See, this one RST, this one is 30 degree, and ROT, they are angle on same segment RT, ROT is at center and RST at the circumference. So angle ROT, that will be 2 into angle RST. So 2 into RST means 30 degree. So that will be also 60 degree. Okay, so this is the answer of question 2. Okay, question number 5. 2 circles are there. First one, in case of first one, center is O. In case of second one, center is O dash. And these 2 circles intersect each other at the point A and B. Okay, in such a way that O, center of the first circle, lie on the circumference of the second circle. Okay, now CD is the tangent of the second circle at the point A. Okay, now you have to prove that OA is the bisector of BAC. That means OA is the, you have to prove, see question number 5. Okay, question number 5. So you have to prove angle CAO is equal to angle OAB. Okay, that you have to prove. Okay, OA is a chord and CD is a tangent. So CAO, that angle, will be equal to OBA. Why OBA? Because OBA is the angle at alternate segment. Okay, OA is the chord. C, application of theorem 12. B is point on the circumference. So OBA, so angle OBA, that is equal to, see this is proof part. Okay, you need to write everything. See, you need to write like CD is the chord at point A, CD is the tangent at point A, OA is a chord, so angle OBA, that is equal to angle CAO, because it is angle on alternate segment. Okay, in case of this triangle OAB, OA and OB, they are radius of the first circle, so they are equal. So that means OA is equal to OB because they are radius of the first circle. They are radius of the first circle. Okay, so OA equal to OB. That means in case of this triangle, so triangle OBA is an isosceles triangle. So that means angle OAB is equal to angle OBA, and this OBA is also equal to CAO. That means OAB is equal to angle CAO. Okay, so that you need to prove here. See this one. So proved. In this figure, question number 6. ABCD is a cyclic quadrilateral where BC is equal to CD. Okay, now TC is the tangent to the circle at the point C. Okay, and DC produced to the point G. Okay. Now BCG is given to you, that is 108. So this angle is 108. Okay. So easily you will get BCD, this angle, because sum of BCG and BCD, that is 180 degree. So angle BCD, that will be 180 degree minus angle BCG. So 180 degree minus 108. So that will be 72. Okay, now you have to join BD. Okay. Now see, you have to find out BCT and DOC, this angle. Now see, in case of this triangle BDC, in case of triangle BDC, BC is equal to CDC. That means this is an isosceles triangle. So angle CBD is equal to angle CDB. Okay, these two angles are equal. So that will be equal to half of 180 minus 72. So that means that will be half of 108. So it will become 54. Okay. So this angle is 54 and that angle is also 54. Now see, CT is tangent, BC is a chord, BCT is equal to BDC. Why? Because BDC is the angle on opposite segment of BCT. So angle BCT is equal to angle BDC, that is equal to 54 degree. Okay, this is the answer of question number 1. Okay, this is the answer of question number 1. Now DOC. Now if you join this DOC, so DOC and DBC, they are on same segment DC, but DOC at center and DBC at circumference. So angle DOC, that will be 2 into angle DBC, and DBC, same thing. So 2 into 54, that means 108. So this is the answer of question 2. See question number 7. In case of this figure, PA is the tangent. See the figure. Okay, PA is the tangent to the circle and PBC is a secant, and AD is a bisects. AD bisects BAC. Okay, so that the triangle PAD, this triangle PAD, that is an isosceles triangle, and you have to show that CAD is half of PBA minus PAB. Okay, so first PA is the tangent, right? PA is the tangent. AB is a chord. So automatically, and C is a point on opposite segment, so automatically BCA is equal to PAB because of the theorem 12, right? Application of theorem 12. PAB is equal to angle BCA because angle on alternate segment. Now see PDA, this one, PDA. This is the exterior angle of ADC, this triangle. See, ADC is a triangle where PAD, this angle, PAD, this angle is the exterior angle of this one. So that means, see, you can write like this, PDA is the exterior, is an exterior angle of triangle ADC. That means triangle PDA, that will be equal to angle CAD plus angle ACD. Now ACD means ACB, or that is BCA. Okay, same thing. Now see this one. So this is PDA, this one, and PAD, angle PAD. In case of this one, that is angle PAB plus angle BAD. Okay. Now see PAD, that is equal to BCA. So you can write BCA or ACD, whatever maybe you can write, plus BAD. See, BAD and CAD, they are equal because AD is the bisector. So you can write CAD. Now see, ACD plus CAD, that means PDA. So you can write from here, you can write PDA. So that means PAD is equal to PDA. Okay. So these two angles are equal. This angle and that angle, these two angles are equal. That means triangle PAD is an isosceles. Okay. Now another part, there is another part. CAD, you have to write CAD. PBA, angle PBA is an exterior angle of triangle ABC, right? So what you can write from that thing, PBA is equal to angle BAC plus angle BCA. Okay, now BAC, that means you can write instead of it 2 into CAD, that you can write, right? 2 into CAD. And BCA, instead of BCA, you can write angle PAB, right? So from here you can write 2 into CAD, that is angle PBA minus angle PAB. So angle CAD, that will be half of PBA minus PAB. Okay. Okay, now question number 8. See two circles. They intersect each other at the point A and B. There is a common tangent, this one, that touches these two circles at the point P and Q. Okay. Now PAQ, you have to show that PAQ and PBQ, they are supplementary. That means PAQ plus PBQ is 180 degrees. So you have to show PAQ plus angle PBQ, that is 180 degree. Okay, that you need to prove. First you need to join AB. Okay, so this is A. Okay, AQ is a chord and B is a point on alternate segment. So ABQ, angle ABQ is equal to angle PQA. Okay, so angle PQA, that is equal to angle ABQ, and similarly QPA, that is equal to angle PBA. Why? Because they are, in case of both case, same logic is given to you. Application of theorem 12, angle on alternate segment. Okay, now if you add, this is 1, this is 2, if you add this 2, what will you get? See, PQA plus QPA, that is equal to ABQ plus PBA. So angle QBA, you can write QBA plus ABP. Okay, so if you add this 2, you will get angle PBQ. Okay, so PBQ, and this one is, see, PQA and QPA. So in case of this triangle PQA, angle PAQ will be, see, differently. If you write, in case of triangle PAQ, angle QPA plus angle PQA plus angle PAQ, that is 180 degree. So you can write this 2 will be 180 degree minus angle PAQ. Okay, so you can write here, so that is equal to angle PBQ. From here you can say. Okay, so from this step you can write angle PAQ plus, if you transfer this term to this way, you will get PBQ plus PAQ, that will be, that is also PAQ plus PBQ, that is 180 degree. That you need to prove. So proved. Okay, so question number 9. See the figure. AE and BC, two intersecting chord, they intersect at the point D, and CDE is 90 degree. So this one is 90 degree. Okay, now AB is given to you. AB, if you join, AB is given to you. AB is 5 centimeter, BD is 4 centimeter. So question number 9, AB is 5 centimeter, BD is 4 centimeter. So AD, that will be BD square, AB square, that is 25 minus BD square, that is 16. So that will be root 9. So it will become 3. Okay, so AD is 3. Now CD is given to you. CD is 9 centimeter, and you have to find DE, this one. CD is 9 centimeter. Now since these two are intersecting chords, that means AD into DE is equal to CD into DB. Okay, so what you can write, since AD and BC are intersecting chords, then this is AE. Okay, AD into DE is equal to BD into DC. Okay, now AD is 3, DE you have to find out. Okay, so AD is 3, DE you have to find out. DE equal to, BD means 4 centimeter, and DC or CD, same thing, 9. Okay, so 9 into, okay, now one thing, so DE equal to 12 centimeter. Okay, so DE is 12 centimeter. See, you have to find out DE. So DE is 12 centimeter. Okay, now if AD is equal to BD, what will happen? See, if AD is equal to BD, from this relation, AD is equal to BD, you can cancel these two terms, to length. So DE is equal to, if AD is equal to BD, that implies BDE is equal to, DE is equal to DC. Now if you add them, that means AE is equal to BC. That means two chords are equal in that case. Okay, so in that case two chords are equal. Okay, if you just need to add this two equation. AD plus DE is equal to BD plus DC. Okay, from that things you can derive this part. Okay, see, in case of question number 10, in the adjoining figure, O is the center of the circle, AB is tangent to the circle at the point B, and BDC is 65 degree. Okay, you have to find out BAO. Now see one thing, first see this triangle BDC. Okay, see, B is the point of contact, that means this angle is 90 degree. So in case of triangle BDC, angle DBC is equal to 90 degree. Why? Because AB is the, see, you need to write AB is the tangent at the point B. Okay, so this is 90 degree. Now angle BDC, that is 65. So obviously angle BCD, that will be 90 minus 65. So it will become 25. Okay, now see one thing, BCE or BCD, same thing, same angle, BCD, this angle. So BCE, if you join BE, first join this one, these two things, BE. Okay, if you join BE, see, angle BOE and BCE, they are on same segment, BE, BOE at center, BCE at circumference. So that will be 2 into angle BCE. Okay, now BCE is 25, so 2 into 25 means 50. Okay, so this angle is 50 and this is 90. So in case of BAO, this triangle, B is 90 degree, O, this one is 50. So this angle BAO, that will be 90 minus 50. So this will be 40. Okay, so angle BAO, that will be 40 degree.